problem number 2. Ingon siya diri. Initially, the car travels along a straight road with a speed of 35 meters per second. So, initial velocity is 35 meters per second. If the brakes are applied and the speed of the car is reduced to 10 meters per second in 15 seconds, determine the constant deceleration of the car. So, okay. If you notice sa itong sample problem number 2, na siya initial velocity. So, di ba itong symbol sa initial velocity, V0, can also write V1, depende sa inyo ha. So, V0 is equal to 35 meters per seconds. And then, pag-apply sa brake, nahinay sa velocity, it became, so, the car is reduced to, velocity is equal to 10 meters per seconds. That is for 15 seconds. So, whereas the, what? Constant deceleration of the car. Okay. So, nag-mention din nga constant deceleration of the car. So, may pasabot ani. So, we know that deceleration is a negative acceleration. It means nihinay siya. So, na mag-term ng constant deceleration, then we were not asked to graph anything. It means this is a constant acceleration nga problem. So, remember that we have 3 equations, diba, sa constant acceleration. We have katong, ito to, the position just equal to velocity, initial velocity times time plus or minus the half of the product of the acceleration and the square of the time. We also have the final velocity is just equal to the initial velocity plus or minus the acceleration with respect to time. Then our third equation, the kinematic equation, the square of the final velocity is just equal to the square of the initial velocity plus or minus twice the product of the acceleration times the displacement s minus s naught. So, sa itong gamiton ani na constant acceleration equation para ma-solve na to ang constant deceleration of the car. So, we have V, V naught, V final, and then the time. Then we ask A. So, the first one, atong gamiton ba? So, this is unknown. We have T, yes. We have the time, we have the initial velocity. But, this is also unknown. So, nanatay dua ka unknown. So, we are not going to use this equation. How about this one? Acceleration is unknown. Kani po displacement, this is unknown. This is only the known. Naitay two unknowns. So, we cannot solve the problem given using this. Dapat usaray unknown. So, we have no other choice but to use this equation. So, we have final velocity, 10 meters per second. Initial velocity, 35 meters per second. We have the time. We are asked the deceleration or the negative acceleration. So, in this problem, we use this V equals to V naught minus A T. So, minus atong gigamit because this is deceleration or negative acceleration. So, substituting the values, our final velocity is equal to 10 meters per second. Initial is 35 meters per second minus the acceleration times time at 15 seconds. So, all unknowns or all variables on the left hand side and then all constants is on the right. So, transpose nato ni siya on this side. This becomes A time acceleration times 15 is equal to 35. Transpose on this side minus 10. So, we have 15A is equal to 25 divided by 15 divided by 15. So, this is 5 times 5. This is 5 times 3. So, cancel ang like terms. So, the acceleration then is equal to 5 divided by 3. That is 1.6666 meters per second squared. Okay? How about sir sa sa first problem lagi wala lagi ta nag-try og gamit og constant acceleration. So if we check the first problem, ipa-graph mo tag velocity times time adto and other graph. So nagamit tag integrals and differentials. So but if you check nimo ang kuan, ang position, di ba? Yang problem ato is 1/2 t cube. Kung i-check ba nimo kung constant acceleration, so ato i-differentiate, no? V is just equal to 3/2 t squared. Yung acceleration ani, derivative sa velocity, is equal to 3t. If makita ninyo na ay variable, it means that ang acceleration changes with time. It means it is not constant. So, mauto siya. Okay? And since this is decelerating, therefore our acceleration is, as I have shown here, is negative. So, this is negative acceleration.